let's just review really quickly. Like if I had these lines just graphed, okay, and I want to be able to write their equation, what would be the easiest thing on here? What do y'all think the easiest part to figure out of that equation would be? The y-intercept, okay? So the y-intercept here is positive 1, so that makes it pretty easy. What does the slope look like it is? 2, okay? It's intended to look like 2. That's supposed to be a point. That's supposed to be a point, so we go up 2 and over 1, and that has a positive slope. So y equals 2x plus 1. That one's pretty easy because we can see where it crosses the y-axis. Well, how about this one over here where we can't see where it crosses the y-axis? Anybody have any suggestions on how they would handle that? Okay, start with the slope. Okay, so that one's easy. The slope here would be -3. Okay, it does have a negative slope. Okay, so, well, what about figuring out that y-intercept? Okay, you could just keep counting with it. Okay, just put them together. Excuse me. You can keep going. All right. So this is the last whole point. So we could go 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 2, 3 off the charts, up 1. I think that ends up at 12. Now, how can we check that? We plug in a point. Like this point's really easy right here, right? Because it's 1, 2, 3, 4, 0. So if we plug in 4, we should get 0 as the answer. So we're good. Okay. All right. So I wanted to review that because we're going to need that for what we're getting ready to do today and leading into Tuesday. So let's look at number 7. Okay. Let's look at number 7 here on your paper. I want to talk about writing an absolute value function as a piecewise equation. Now, I think you've seen a little bit with piecewise functions in Math 3, a little bit. I'm going to go just from scratch. If you look at the absolute value function, when you graph it, it looks like 2 lines, right, that just intersect with each other. Somebody said that the starred value is where they change, okay? And that's absolutely correct. So when we're trying to figure out how to write this as an absolute value function, I'm going to start by taking what's inside the absolute value, set it equal to 0, and solve for x. Okay? This is what I call the changing point. There's probably a more technical term for it, but that's what makes sense and it helps you remember. Okay? That is the changing point for our piecewise function. Now, I always make sure that I do this very methodically. For the first part of my piecewise function, I change the sign of what's in front of the absolute value. I change the absolute value bars to parentheses, and I'm going to simplify that expression right there. Okay, so for the first part, I always, change the sign in front of the absolute value, change the absolute value bars to parentheses, and we're going to simplify. So you have to be careful with this. You really do have to be careful because you're going to have to distribute a negative at some point in time. You get negative 3x plus 12 minus 3, so that simplifies to negative 3x plus 9. If you look at the left side of that absolute value function, that should be the line negative 3x plus 9. Okay, I think, 9 is kind of off the scale of your picture, but you should be able to see that it's headed towards a y-intercept of 9, and you should see that it has a slope of negative 3. So this is the left side. For the right side, you don't change anything. Okay, you do not change anything for the right side. You just drop the absolute value bars. They turn into parentheses, and you simplify that one. 3x minus 12 minus 3. So 3x minus 15 is the line that represents the right side of that absolute value function. You should see it has a slope of positive 3. If you were to extend it, it would have a y-intercept of negative 15. So to write this as a piecewise function, we write y equals, we put a big brace right there because we're going to have two lines. I always do the left side first. So I put negative 3x plus 9. That is true when our x values are less than 4. Okay, that is true when our x values are less than 4. Then our graph looks like 3x minus 15 when our x values are greater than 4, to the right of 4. It doesn't matter which one of these. One of them needs an equal to. It doesn't matter which one you put it on. If you want to put it on the first one, if you want to put it on the second one. For these, it does not matter. Okay, so this is exactly the same graph or function as the absolute value function up there. It's just a different version of it. This is the piecewise. Let me write that out so y'all know what it looks like. Piecewise function version. Okay, that's the piecewise, but it's the exact same function as that absolute value function at the top. Yes, sir?
Why is the left side less than?
Okay, so if we think about split, that's a good question. When we think about splitting up our graph here, we know it changes at 4. So when x is less than 4, you're talking about the left side. You're talking about values to the left of 4. Okay, if x is 0, 0 is less than 4. It's to the left of 4. Over here, your x values are greater than 4. Okay, your x values are greater than 4 on the right side. 6, 7, 8. Okay.
If the y value equal to.
It doesn't matter which one gets the equal to. Either one, in this case, either one can get the equal to. It does not matter. Okay? All right, so I want us to practice with this. One more thing that I need to point out, though. On, like, number 8. On number 8. In order to write it correctly, piecewise, when the coefficient with the x is negative, like with number 8, it's negative 2x inside the absolute value there. You've got to factor out a negative 1 to begin with. So this is what I'm saying. I'll get you started on number 8 here. We've got y equals negative 2 times the absolute value of negative 2x plus 3. Turns out that is the exact same thing as negative 2 times the absolute value of 2x plus 3. Okay? Okay. Okay. All right. John Hicks, Tara Blevins, Side, Alex, Daniel, Aaliyah, Casey, and Mark. Thank you. Wow, have fun. Have fun.
Yeah.